It's my pleasure to present the PANDA project, which is composed of 11 partners from 6 European countries, from university to industry, including SMEs. When we develop innovative vehicles, we can use the V or W models, which is composed of design axis, a testing axis, and a virtual testing axis. And as you can see, there are many tasks where there are some simulation with different simulation tools, and some components are developed several times with different models, accuracy, that can lead to some issue in terms of flexibility and the development time. The objective of PANDA is to develop an open access model organization of all the model in some of the tasks of the W model. And a cloud of model will enable to share the models for the different tasks. In that method, we hope that we can reduce the time to market by 20%. The method is a disruptive one because first we will use a simulation based on functional approach, on the contrary of the classical software that are based on structural approach. That means that before the simulation, the user are to pre-solve some conflict of association between components, but the interest is to reduce the computation time and to increase flexibility. In that aim, we will use EMR, an energetic macroscopic representation, which is a graphical formalism in order to organize model and control of energy conversion system. The second main point of PANDA is to develop a cloud of models. On the contrary of actual ongoing project, we would avoid to have co-simulation of different software and use a common cloud and common software that can lead to have a seamless interoperability and more real-time simulation capability. So University of Lille brings the EMR-formalism in the project. Siemens brings Simcenter Amesim software in order to demonstrate that this method can be integrated on actual software. And we have 3 study cases. A pure electric vehicle or battery electric vehicle from Renault, a fuel cell vehicle from another European project and Université de Bourgogne-Franche-Comté, and hybrid vehicles from Valeo company. The Simcenter Amesim software is a well-known advanced multi-physics industrial software, very used in automotive sector, and as classical software, they are based on structural library with different components that can be interconnected as in the real life. But in the perspective of PANDA, we have developed a specific functional library based on the EMR philosophy. For example, with a very simple battery electric vehicles, after the modeling step with equation that represent the different component, we have to use EMR in order to organize all the parts respecting input and outputs. The system is in a range, and we can then systematically deduce the control scheme in blue. Then, thanks to the new library developed by Siemens, we can transpose very easily the system in the simulation package. One of the interests to keep input and output fixed is that we can change very fastly the different level of models for the different components. For example, we can have a battery with a level with low accuracy or medium accuracy or high accuracy, which is more complex and is the same for the other component. All the component has been developed by the partner and capitalized in the cloud with the library and the software. And now we are able to simulate the full vehicles, the full reference vehicles with the different partners. There is two ways to do simulation. The first is standalone simulation. In that case, the user uploads simulation file in his own computer and run the simulation locally. In the second way, which is called cloud computing, the user is connected to the cloud, compose and builds the simulation within the cloud and run in the cloud the simulation to get the result. An important thing is that some part of the model will be developed in a black box approach in order to keep the confidentiality of some new innovative component. The three reference vehicles have been simulated using that methodology. I just will present the result of the studied battery electric vehicles, which is the Renault Zoe. We can decompose the system in four subsystems in interaction. And you can see here the EMR of a very simple model of the system. In green is energy sources like battery. In orange is energy converter like the electrical drive. And in blue is the control part. Thanks to the developed library, we can build different levels of systems. And for example, in this slide, you can see that we have a more complex system for more complex model 3 for the electrical drive and the chassis. For the battery, in order to give you an example, we have developed several levels of model. I just present two. The first one is a pure electric model. The second one is a more complex, taking into account the thermal effects. All the parameters of this model has been identified by the Vrije University of Brussels. We do the same with the electrical drive. I just present two models, a very simple one with a step-tip map, efficiency map developed by Renault, and a more complex dynamical model, including saturation effect, developed by University of Cluj-Napoca. But all the time, input and output are strictly the same for both models. That means that we can replace easily one model by another. All this model has been validated by experimental tests. For the Renault Zoe, Renault do some real driving cycle. The velocity are used as input, and then we can compare simulation and experimental results. You can see that the results are very close, and in terms of energy consumption and state of charge, the error is lower than 2% for any driving cycle we have studied. Another interesting fact is that we compare a classical simulation using a structural library, because Simcenter Amesim is a structural software, with the new functional-based library. And for the same model, the same control, same accuracy, we have a reduction of the computation time by 15% for the functional library. The next step are to use the cloud of model in order to realize hardware in the loop testing. We will consider the plug-in hybrid vehicle from Valeo in order to test the electrical part with an interaction with the other parts simulated in real time. To have an example, I will consider the testing of the battery developed by Bluways. It is interconnected with a power interface and real-time simulator developed by Typhoon, which is connected to the cloud. There is two ways to proceed. The first is to upload the file on the cloud and to do the testing locally. And the second, to split the simulation model in the power interface and in the cloud in order to have cloud-based hardware in the loop with real-time exchange of data. So in order to conclude, we can say that we have successfully realized a cloud of model using a unified method. And this cloud has been used to simulate the free reference vehicle. Nowadays, we are working on the usage of the cloud for Arduino Loop testing of the plug-in hybrid electric vehicles. And we have to estimate the reduction of the time to market thanks to this method. Moreover, we are estimating the CO2 equivalent emission due to the project by the traveling, the tests, and so on, and we will develop some mitigation action. Thanks for your attention, and if you would like to have more information, you can have a look on our website.